Master of Studies. But wait ko lang siya guys ha, mag-try lang muna ako in my future endeavor. Could I make it or not? It's up to the Almighty Lord God to help me with that journey. Okay? Talaga, kaloka. Okay, going back, I love to become ano talaga guys, I love to become a legit professor in reputable universities. Like that. International or local universities. Oh my gosh. Okay. Let's go back to the topic of normality again. Okay. Guys, normality. Okay. So as I said earlier, over and over again, normality and molarity is just, complementary with each other in concentrations expression. These are normally used, especially if you have your own chemical business to concentrate the products, to dilute the products, or how much concentration you want to your product so that it could meet the satisfactory requirements of the buyers of your product, something like that. And that it could not be more concentrated, more diluted, and you have to adjust the proportion also according to the available resources and technology that you have in your own business, something like that. Okay, this is not related only to beverage, food products. It's also in the, for example, plastics, rubber, like that, or any kinds of products. But normally you have to start in a small scale, and then after that, if you found out that your business will become successful and you will extend your business to a little bit bigger. Of course, you're going to do it alone without the partnership of other investors also. If you have friends who really love to invest about chemical products, then you join with them or engage with them. So it's going to be a sort of corporation. Okay? So it would be better also that you are really having the license to operate, because it's not allowed in the Philippines if there's no license to operate, especially if you're operating a chemical business. You should at least be a licensed chemical engineer, something like that. Or anyhow, you can represent that with other people also. Then hire them in your businesses so that the signatories will be approved to the release of the products in the worldwide scale, or it can be in the local scale like that, okay? Because it's really a law. Okay, you cannot practice to do business in a large scale if your engineers are not licensed in the government. Okay? That is really the case if you practice to produce and to manufacture products that could be patented to, di ba, may anak, DFA, mga ganon, or whatever sectors in our government, something like that. Okay? So, normality and molarity. Okay, mga palangga. Okay. Related din siya guys, because I love normality. Let's do first, okay? Normality is equal to number of equivalent, okay, over the liter of solution. Then it can also be expressed as gram equivalent over liter solution, and it can also be expressed as EW, equivalent weight, over the liters of solution. Am I correct? Equivalent weight, okay, then liters of solution, or number of equivalent weight, something like that. The key term here is really the word equivalent. Okay, because sometimes it will be used interchangeably, and then the word equivalent is very important. And then the mechanism of how you try to calculate that, then that would matter a lot. Okay, it's not really the terminology, but the mechanism, or the methodology on how to calculate that certain quantity or variable is the most important one. And then you have to complement, and you have to link and correlate that also, of course, with basic concepts and principles also to be applied. Okay, like that in a particular context that you're trying to discuss with your audiences or in your students, whether in a classroom instruction setting, or whether in a conference or a training room or whatever, or any large scale conferences and trainings pertaining to the topics of the expression of concentrations. Okay, now it's gonna be like that. Okay, now we have another three versions of the first versions to compute for the equivalent. The number equivalent, okay, mga palangga, is equal to the number of moles. So what's this number of moles all about? Is this referring to the stoichiometric relationship in the chemical reactions? Or would this be referring to the dissociation reaction when the compounds will dissociate into the aqueous solution to produce a positively charged particle and a negatively charged particle? Or could it be a Lewis dot chemical bonding? Or a bronzoglory acid and base through chemical reaction? Or it could be another way of expression through redox. Okay, the oxidation and the reduction chemical reaction as well. Reduction as well, sorry. My tongue is twirled. Oh my gosh. I hate drugs. Okay, so this number of moles, guys, is not a stoichiometric relationship reference, but it is really according to the given expressed in your problem. Ganon, di ba? Okay. So, usually, mag-start siya sa grams or moles also, but most of the times, based on my experience through solving problems and reading a lot, also when I was in college and up to now, it's always grams. Okay, but it depends on the situations, huh? It doesn't limit it to particular topics that you are trying to read in the references in the social media or in the internet references. Okay? Ganon. So times the n factor. Okay, the n factor will be basing on the Arrhenius theory of acidity and basicity. Okay, so you should remember that concept also before proceeding to higher topics in chemistry, the basics. Start with the basics, especially in organic chemistry also. You have to learn the study of the salts, the acids, the bases, the oxides, the alcohols, the different chemical reactions like that. So it talks about matter. Okay, you know matter, anything that occupies space and has mass. And of course, if you study matter, you have to undergo the in-depth study of different changes it undergoes. Could it be a physical changes, a chemical changes, or a phase changes? Okay, it's gonna be like that. Okay, so going back to the end factor, it's gonna be the OH negative and the H positive. By theory, guys, H positive would mean also a hydronium ion positive. Okay, this is the same. Hydronium ion positive. H3O. Ganon. Since hydronium ion is very difficult to produce, though it can, but it's not common because of the three subscript reflected in the hydrogen at the bottom part. So we would like to emphasize always the hydrogen positive one. Okay. So if we put positive and negative, meaning to say that your compound could either be base or acid already reacted to any solvent to produce a solution so that it will become charged. It will break up and individual elemental constituents will yield a charge, could either be positive or negative. Okay? Positively charged ions are called protons. Okay, negatively charged ions are called an ion. And proton also the same as cation. Okay? Cation, positively charged particles. Okay, or ions. Nakakaloka. Okay, going back, this is the first version. Okay, mga bro, any questions so far? I'll try to slow down my communication skill because my weakness is really I talk so fast. And then anybody cannot understand what I'm talking. I'm very, very speedy. Wow, speedy. An adjective referring to the person who talks very fast. Speedy, right? My gosh. Okay. So we have now here, and then number two, we have also the equivalent weight of solute. Okay, what is the formula of the equivalent weight of solute, mga palangga? Okay, it's gonna be equal to the grams. Okay, ganon. So one equivalent weight of solute is equal to the grams. And now, we will consider always the 1 mole of OH. For Arrhenius also. Okay? OH negative. 1 mole of H positive. You will start that as your basis of calculation in equivalent weight of solute. Until such time, you will yield a gram somewhere in the final result. Your target of your computation and calculation is really a gram. Now, before going to gram, it will yield onto the positive moles in the chemical reaction. Positive moles in the chemical reaction. Okay? Mga palangga. Okay. Example. Okay. Calcium hydroxide. Okay. Does calcium hydroxide is a strong base or not? Okay. Which is a strong acid? Sodium hydroxide or calcium hydroxide? That is not our topic, but I'm just asking. Okay, so calcium hydroxide. Okay, mga palangga, calcium hydroxide, blah, 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 so and so. So, if we will add water, it will become aqueous solution. Right? There is a solute and there is a solvent. And then this calcium hydroxide will dissociates into calcium positive 2. Okay, ganon. Plus OH negative, then 2 moles. Why? Because you have a subscript of OH. Okay? You get the point? And we cannot put 2 in the bottom of OH because there's no rule in chemistry about that. So automatically, by default, it will go to the beside of oxygen and hydrogen. That's why twice or 2 moles or 2 coefficient of OH negative. Okay, ganon. So, calcium hydroxide, you get the H, then that is 2 moles of OH. Okay? Ganon. So, ano na yun? 1 mole of OH, which is your basis of calculation, 1 mole of OH negative times 2 moles of OH negative in your dissociation, and then the mole also of calcium hydroxide. Pila man. So, 1 mole of calcium hydroxide will yield this dissociation products. Okay? Calcium positive 2 and hydroxide negative 1. So, we have 1 mole of calcium hydroxide. Ganon-ganon siya mga kapatid. Okay? And then, if you have the volume mga kapatid, so it's now become a moles per liter. It is molar already. Okay? Any questions so far? Because if you have the problem of a liter data, for example, what is the normality of a solution that contains 50 grams of calcium hydroxide dissolved in 15 liters? Okay, like that. Because of too much exposure to different problem solving in chemistry, sometimes we can fabricate our own problem and question. Okay? You need to refer to the book. Okay. Get the point? So we should exercise our brain cells to that type of attitude and culture. Okay? Like mga engineers and engineering students. Okay. Going back. Okay, so the positive 2 is here. This will be your N factor. Okay. I have to erase this mga palangga because I have no enough space in my whiteboard. Okay. So how can I do this? Okay. Now, we will be very, very particular with the units of measurement. Okay? Units of measurement, or to quantify and to measure certain amounts or any compositions. Okay? N factor. So, we have now the number of moles, then moles. Ganon. Moles of your solute, of course. Times the N factor. Okay? Like that. So, it should be equivalent per mole. So that mole will cancel. What will retain is equivalent. And this equivalent, okay, you will put that here in your formula of the normality. Okay, something like that. Okay, mga palangga? Ganon. And this mole here will also relate relate that, guys, and link to the molecular weight or the molar mass. Okay? If your problem has grams or mass given, ganon. Okay, mga palangga, wala siyang tabo karong higayon na. Okay. And the other normality is very easy. Okay. That's usually comes out or came out in the board examination. Is the most, shall I say, simplified. Normality 1, volume 1 is equals to normality 2, volume 2. This is the favorite, right? Of all. Like this. Okay, and given the other one base and the other one acid, so this is basically titration. You titrate an acid and a base in a neutralization reaction, and you produce hydrolysis products, the reaction of salt and water. Okay, so in a burette, there are two burette like that, and then you will be able to titrate. And then if you're the end point, the color will change. You will stop your titration because already happening the chemical reaction, and you can obtain the desired result, something like that. Okay? So that is your normality. Version 3. Okay, what is the version 4? The version 4 is normality is equals to the molarity times the replaceable OH negative or replaceable H. So if you take for the normality of the base, you will say molarity times OH negative. Normality of the acid is equal to molarity times the H positive. Ganon. Okay. Now, the story of the problem solving is, a little bit tricky because sometimes the problem also will just show the pH value. And you'll try to ask, what is the normality? And there's no molarity, but the pH is given. So, you will take note that pH, like that mga palangga, is equal to the negative logarithm of the H positive concentration. So, in that, you can solve for the value of H, and then you will substitute that here. In your normality of the acid is equal to the molarity times the H. Okay? So you will never go to the replaceable in the chemical reaction if this is the situation in the problem, given the pH. The measure of the strength or the acidity of your acid, because it's acidity, of course, common sense. Okay? It's the measure of the strength of the substance. That is pH. Okay? Like that. And then, if you try to compute for the POH, pH plus POH is equals to 14. This is POH is also the measure of the strength of the base. Okay? And you will compute that POH equals to 14 minus pH if the pH is given also in your problem. And then substitute that here if you try to compute for the normality of the base. Okay? Ganon. Di ba kanon mga palangga? Okay. So, imo na siyang tinanaon pag-istorya. Charot! Diba? Okay. Pero kung masayon, kag gusto, kag sayon pa, she will use the H talaga. Nawala na siya yung logarithm. So, like this. Concentration of H is equals to the base 10 exponent to the negative pH. And then OH negative will be base 10 raised to the power of negative OH. Because there's no negative base 10 in the calculator. It will syntax error. If you try to use the scientific calculator, there will be no such thing as negative base 10. It's always positive. That's why it go up the negative sign in the exponent. Okay? Or raised to the power exponent, blah, blah, blah. Okay? Ganon. Okay, but normally guys, if you are working in the university or institution laboratory for the purpose only of, taking general chemistry lecture and then the laboratory, then a lot of chemicals there, and as far as I can remember, so many chemicals there inside the chemical laboratory. There's a labeling of molarity, right? Then you can compute that immediately by the normality through the replaceable OH. No need to dissociate like that. Sometimes you can memorize already what's going on in your brain cells. For example, 0.5 molarity H2SO4. Calculate the normality. 0.5 times 2, kalas. No need to dissociate the H2SO4 because this is expected that it will yield twice of the H positive. Okay? Because of the presence of 2 here in the hydrogen. Okay? You get the point? Not a good for me. And then for calcium hydroxide, called 0.4 molarity of calcium hydroxide. So, what is the normality? By looking alone, 0.4 times 2.8. Ganon. Because 2 sa ang hydroxide. Because hydroxide is 2. Automatic lang siya through visual inspection. Okay? No need to complete too much. Okay? Like that. So there are 4 versions. Okay? You get the point, mga kapatid? Thank you so much for liking or commenting something in the comment section. And if you want also to share in the benefit of understanding, then you can also share. And then you can subscribe my YT channel if you want also. And click the notification bell for some news updates. And I am a singer, Eternal Voice. Bye bye, God bless everybody. See you later for the problem solving. Okay, ganon. Mga palangga.